Let's talk about using switches as sensors for the Arduino. Switches are the basic and the most simplest type of sensor we can connect up. As you say, the simplest sensors are switches. You can have switches throughout your ROV. You can have different types of switches. And if you look at the most complicated sensor system, many of them can be broken down into a simple switch. For instance, the float switch. It's a simple switch inside there that has an actuator that is operated by the float, and the float moves as the water moves. As water raises, the float raises, which causes the actuator to push on the switch and close it. As the water drops, the float lowers, and then the actuator then pulls on the switch and opens it back up. It's a very simple switch open and closing mechanism, but not so simple mechanical mechanism for the float switch. Another example is an inductive switch. You bring it close to metal and the switch closes, you take it away from metal and the switch opens. So we're going to cover a number of items in this presentation. How do we connect the switches to the Arduino? What voltages can we use? What are voltage dividers? What about putting switches on the end of a long run of wire? It's typical with an ROV that maybe you want to control the ROV from the surface with the Arduino down inside the ROV. Can we do that? And some examples of switch-based sensors. So we're going to connect a switch to an Arduino. What can we use? Well, to start off with, we can't connect 12 volts to the Arduino. That will blow it out. Arduino can directly connect to any sensor that switches between 0 to 3.3 volts or 0 to 5 volts. And the Arduino sees any voltage from 0 to 1.5. Anything within that range is seen by the processor as a logic 0 or off. Any voltage from 3.0 to 5.0 is seen by the processor as a logic 1 or on. Now, as long as the switch is controlling a voltage within these ranges, you can then connect it directly up to the Arduino without any problems. Here's an example. We have 5 volts coming from the Arduino, and then it goes over and connects up to R2 and around and connects up to input D8. Now, switch 1 is open. The voltage at D8 is 5 volts. On the other side of the switch is connected to ground. So what happens then if that switch closes, input D8 is then connected to ground, and you'll read 0 volts at that pin. So switch open, D8 reads 5 volts or a logic 1. If it's closed, it reads 0 volts or a logic 0. So any signal that is less than 5 volts we can utilize. If the voltage of the switch is higher than 5 volts, then you've got to go through a voltage divider or some other type of isolating device before connecting to the Arduino. And voltage dividers. Well, we'll talk about this. It's simple 2-resistor voltage reduction. We need to know some things first. What is the voltage being switched? Are we switching 12 volts, 24 volts, 48 volts? The maximum voltage at the Arduino pin. Well, we know that to be 5 volts. And the lower resistor value, we're going to set that at 1 k ohms. And then we're going to calculate the upper resistor value based upon the voltage we're switching. So here's an example. We have a sensor out there that it needs to run off of 12 volts. It'll provide you with a 0 to 12 volt signal, but that doesn't work for the Arduino. Its maximum is 5 volts, and we saw earlier that anything between 3.3 to 5.0 is considered a logic 1. So let's give us a little headroom there and use 4.8 volts. So 12 volts divided by 4.8, with a lower resistor of equal to 1000 ohms. And then here's the formula for the upper resistor. You have 1000 times Vn divided by Vmax, and then you subtract 1000 from that. And if we go through the math there, that works out to an upper resistor of 1500 ohms. Here's an example with a voltage divider used at 12 volts. It's the one we just did our calculations for. You can see the lower resistor here, 1 k ohm, and then the upper resistor that we calculated, 1.5 k ohm. These two are connected in series, with the lower resistor connected to ground, the 1.5k connected to the switch. The center point between those two resistors is then wired up to the Arduino pin. Now here's the same circuit over here, but showing with the switch closed. We'll work on this part here with it open first. When the switch is open, the 1.5 k ohm is floating, and this pin, the Arduino input pin, is held down to ground or 0 volts through the 1 k ohm resistor. So if we put a voltmeter on here and read that input voltage at the Arduino pin with the switch open, we're going to read 0 volts. Now when the switch closes, we'll have 12 volts applied to the top of this voltage divider. If you go through and do your math, you'll find out that we'll now have 4.8 volts at this point at the 1 k ohm resistor and at the Arduino pin. We put our voltmeter on there and measure that. We'll have 4.8 volts between there and ground. So switch open, we have 0 volts. Switch closed, we have 4.8 volts. Very nice. Now, what about long runs of wire? Can our switches on the surface be connected to our Arduino inside the ROV for control? Well, short answer is yes, but a more correct answer would be yes with the proper connections. If you just run a switch up to the surface, switch some voltage, run it back down, you're looking for danger. You're looking for problems, because these long lines introduce wild voltage spikes at the Arduino input pin. And that's done through inductive coupling between the control wires, which are connected to the switch, and the power wires, which end up running your motors and your thrusters. As those motors turn on and off, there's large inductive spikes on the power lines, and those can easily couple into your control lines and burn up your Arduino if done improperly. So what do we do to protect it? We need to limit the range of voltage applied with a minimum of 0 volts DC and a maximum of 5 volts. Negative spikes below 0 volts, a negative going voltage, will take out an Arduino input, and also going over 5 volts. Okay, this can be done with two easy methods: a resistor diode network to limit the voltage swings, and that's made up of a resistor and 2 diodes, or an opto-isolator. And truly, the opto-isolator is the most optimum way to do this and will provide you with the most isolation and protection for your Arduino. We'll go over this more later on in the course. Some examples of switch-based sensors: a photo switch. You have light, the switch closes; no light, it opens up. A push button. Push a button, turn on an actuator. Let go of the button, turn it off. There are digital temperature sensors out there that you can set with an alarm set point, so if the temperature inside the ROV exceeds a certain level, the switch can close and let you know that it's getting pretty hot in there. A metal touch sensor. You bring that inductive sensor and the switch hall sensor. Both of those are different types of sensors that provide an on-off output. Okay, the next steps, we're going to write a program to read a switch, and then we'll control an LED to follow the state of the switch. The switch is off, the LED is off. The switch is on, the LED is on. Next, we're going to blink an LED for as long as the switch is pushed. That shows a little bit more control than just a simple on-off. Now we're going to turn on an LED to follow the switch, and blink a second LED when that same switch is pressed. So this is an example of controlling two outputs with one input. And then finally we're going to turn an LED on if two switches are both closed. Now this is controlling an output with two inputs.